We talked about the 2023 El Nino, and some papers have reported that it was an ocean dynamic El Nino. So the coupling between the ocean and the atmosphere wasn't as strong as you would expect during an El Nino. The whole Biekness feedback didn't happen except in the coastal region, and that too during spring, not during peak El Nino. This paper adds a bit more to the 2023-24 El Nino and shows that the extratropical teleconnections of El Nino, what we expect from El Nino in terms of remote forcing, was unusually weak compared to other El Ninos. It just says that the uncoupled behavior probably contributed to this, which shows up through weaker precipitation anomalies in the tropical Pacific, which again is consistent with not being fully coupled to the atmosphere. It was mostly ocean that was driving the warming, which qualifies as an El Nino, right? The El Nino Southern Oscillation is a major driver of global climate and weather variability through atmospheric teleconnections. However, the 2023-24 El Nino event, despite ranking as the fourth strongest since 1979, exhibited an unusually weak Pacific North American pattern, or what is known as a PNA pattern. Here we show that this unexpected behavior is due to anomalously weak tropical Pacific rainfall changes, a key driver of teleconnections associated with El Nino, in the sense the shift of the heating center and the anomalies in the heating center send off signals across the world, which the heating is very critical. If the heating is weak, then the teleconnections will be weak. Through analysis of observational data during 1979 to 2023 and performing atmospheric model experiments, we further revealed that the suppressed tropical Pacific rainfall changes were caused by unprecedented warming in the tropical Indian and Atlantic Oceans in 2023. We already invoked these warmings as the causes for weakening the Walker cell and releasing the warm water that had piled up because of the multi-year La Nina from 2020 to 2023 before the El Nino took off. This warming, partly driven by long-term trends exceeding those in the tropical Pacific, has amplified the influence of these extra-Pacific basins on El Nino dynamics. Notably, current climate models fail to reproduce this interbasin warming contrast, highlighting critical challenges in their ability to predict future climate impacts associated with El Nino events. This is why I keep harping that going out to 2100 with all kinds of crazy scenarios is not producing very reliable information, but now it's a big ship that is hard to steer or hard to stop. So that business will keep going. IPCC AR7 is already getting geared up. Hopefully they will spend more time doing decadal predictions and not obsess about 2100 with all kinds of scenarios, because the uncertainties in the projections are dominated by scenario uncertainties as you go beyond a few decades of projection. And if you look at all the crazy things happening in the world right now, how easy is it to imagine future scenarios? Not easy at all, right? Even if you write a fiction about what's happening, we won't believe it. We will think it's science fiction. Orwell did 1984, which was great, but anyway, I digress. So here we are looking at the observed characteristics of the 2023 El Nino. During winter of 2023, peak El Nino, Indian Ocean had maybe a weak IOD kind of thing, and the tropical Pacific was warm. The point is these warmings are more rapid than the Pacific warming signatures, and hence they could affect the Walker cell and SSTA percentiles. You can see the top 95th or higher occurred in the Indian and Atlantic Oceans, and precipitation in the Pacific versus the Pacific SST anomalies were along here, but they should be on this line with La Nina and El Nino, but 2023-24 was out of this range and barely showed any Pacific precipitation signature compared to the level of warming associated with Nino 3.4. And you can also see other big El Niños here, which are very much on this regression we would expect, correlation we would expect. At the surface, you had again weak winds, so westerly wind bursts, which are part of the coupling, didn't happen. Pacific North American anomaly mode didn't happen. So where you should be in terms of SST anomalies of the Pacific and the Pacific North American index, which is related to precipitation and winds at 850 hectopascal level, millibar level, which is basically at the boundary level, boundary layer level. And again, 23-24 was way out of what can be expected with the Pacific SST anomalies. Okay, this is about extratropical teleconnection patterns during El Nino events. These are DJF mean precipitation here. Let's make sure we get it right. Precipitation in millimeters per day and 200 hectopascal geopotential height anomalies in meters, and these are in millimeters per day in meters, of course. 200 hectopascal. So in the color you have precipitation and you have 200 hectopascal winds. What you got in 23-24 is very distinct from what we got in 82-83. Look at the precipitation anomaly, how much stronger it is with the shifted warm pool and the deep convection. Here very weak, basically like a anomaly in the ITCZ and SPCZ rather than a real shift in the convection from west to east, despite the warming looking like an El Nino. 15-16 also had strong shifts and PNA pattern, which is of course this one, Pacific North American pattern. It tends to have this kind of a circular pattern. If you want, you can read it elsewhere or listen to podcasts on my channel. 97-98, same story. 2009-10, which was a weaker El Nino, also same story. Very distinct 23-24. This is 850 hectopascal zonal winds averaged over 5 south, 5 north, and you expect weaker trade winds. It depends on what time scales you look at. You look at monthly means. You will not be going after westerly wind bursts, which are synoptic events. You will look at trade wind anomalies, right? So the role of tropical Indian and Atlantic oceans, DJF mean 200 hectopascal velocity potential, geopotential height, velocity potentials, they all have significance in terms of relating upper level convergence, divergence to surface level heating or surface level anomalies, mid-tropospheric heating, and so on. That's why we look at it. This is the Pacific, let's make sure, 200 hectopascal potential and geopotential height. So you have DJF mean 200 hectopascal velocity potential anomalies shown are different experiments. So they are model experiments, and they obviously, when you do model experiments to separate the impacts of warming outside the Pacific, you are going to do experiments with the warming and without the warming and so on. So they are both showing basically that if you remove the let's just read it properly. I try to be stingy on reading long captions because figures are very informative, but nonetheless sometimes they are necessary to read. Shown are the differences between experiments forced with Pacific SST anomalies alone and the control simulations, which has all forcings. You can read the methods. B is as in A except for 200 hectopascal geopotential height anomalies. This is the DJF mean 200 hectopascal velocity potential anomalies. This is 200 hectopascal geopotential height anomalies for the Indo-Pacific, Indo-Atlantic, Indian and Atlantic oceans. So B as in A, except for 200 hectopascal geopotential height anomalies. C and D are as in A and B, except for changes caused by SST anomalies in the tropical Indian and tropical Atlantic oceans, represented by the differences between experiments forced by all three regions, and so on. So essentially, you can include the warmings, remove the warmings, and look at the differences with all the forcings and argue that the unusual 2023-24 anomalies in PNA, tropical precipitation anomalies were all related to Indian and Atlantic Ocean forcing because of their warming being so much stronger than the Pacific. Here we are looking at the 850 hectopascal zonal wind anomalies average between 5 south 5 north due to SST anomalies in the three tropical oceans. So that's the gray shading here. So you have negative zonal winds, which correspond to trade winds. Easterlies in the far easterlies are positive, westerlies in the far west, and easterlies in the central to east. If you do Pacific only, essentially you didn't get a weakening of the trade winds and Bjerknes feedback, etc., as you would expect, and Indian and Atlantic signals are here in the zonal winds as well. Okay, so you get the message. These are confirming the trends from HARA-SST. This is a really critical lapse in deficiency in the models. If you look at CMIP6 ensemble mean SST trends per 3 decades, models are way off, way off. So this is okay. This is looking completely wrong. This is partially okay. When you have something so distinctly wrong in this critical region, if things look okay here or here, what does it mean? Is the mid-latitude signature somehow disconnected from the tropical warming signatures? It's not always clear. Okay, so Indian Ocean, Pacific Ocean, and Atlantic Oceans, you can see the warming of the Indian and Atlantic Oceans are here. Pacific Ocean is much more flat compared to the Indian and Atlantic Oceans, which we already saw. So let's just jump to the discussion. I think I'll just make it brief because the main points are made twice now. One, the 2023-24 El Nino was an ocean dynamic El Nino because the usual weakening of the Walker cell and trade winds that is required for kicking off an El Nino happened because of Indian and Atlantic Ocean warmings, and the same warming also affected the coupling in the deep tropical Pacific. Didn't get a strong precipitation signature, which means it didn't get a strong extratropical teleconnection in terms of the Pacific North American pattern. That's the main message. The year 2023 was the warmest on record since the Industrial Revolution, marked by an unprecedented amplitude of pantropical warming that played a critical role in suppressing ENSO-driven extratropical teleconnections. 2023-24 peaked during boreal fall and slightly weakened the following year. So it's not a typical December, January, February peak, failing to meet the threshold for Super El Nino with an unnecessary addition. It's not scientific, so please ignore those kind of things. This lack of further development in winter 2023 has been partly attributed to the warming of tropical Atlantic and Indian Oceans, despite the favorable warm water accumulation in the western tropical Pacific during the triple dip La Nina of 2020-2023. Nevertheless, 2023-24 El Nino was still classified as a strong event with significant Pacific warming. However, it exhibited a much weaker than expected atmospheric response in the tropical Pacific and extratropical teleconnections compared to the other strong El Nino events we just saw in the figures, 82, 83, 97, 98, 15, 16. While our primary focus is on the role of tropical Indian and Atlantic Ocean warming in counteracting the weakening of the Pacific Walker circulation driven by tropical Pacific SST anomalies, these two basins can also directly influence the Aleutian low through atmospheric teleconnections, which gives us the PNA. Aleutian low is basically sitting here. Okay. For instance, previous studies have shown that warming in the tropical Indian Ocean can induce high pressure anomalies over the mid-latitude North Pacific, partially offsetting the strength of the Aleutian low caused by El Nino remote impacts. Similar processes may have occurred during the winter of 2023, further diminishing El Nino's influence on the Aleutian low. Just jumping ahead, the underlying cause of the interbasin warming contrast in the tropics over recent decades remains uncertain. Natural climate variability, such as the phase transition of the interdecadal Pacific Oscillation, that is called IPO, from positive to negative, may have contributed to this pattern. When you have natural variability that persists for decades, then they are creating essentially secular trends. You have global warming going on, which is an anthropogenic time scale, century time scale. Then you have multi-decadal warmings that can be constructively interfering with the global warming, right? Additionally, anthropogenic greenhouse gas emissions could be driving uneven warming trends across tropical ocean basins. It's already argued, I have podcasts arguing that Indian Ocean warming is controlling the heat uptake in the Pacific Ocean. Pacific Ocean heat uptake is getting into the Indian Ocean through the Indonesian through flow. Indian Ocean warming is also argued to affect the Atlantic meridional overturning circulation. So Indian Ocean is a little ocean, but it also gets warming from the Southern Ocean within about a decade or so. So it's a little ocean that may be having disproportionately large impacts on global warming and modulation of natural modes like El Nino. Okay. However, notable discrepancies persist between current climate models and the observed tropical warming patterns of recent decades. Eastern Pacific cooling is not being done, as Richard Seeger has been writing a lot about. Nevertheless, our findings underscore the critical role of this pattern in modulating the relative influence of the three tropical ocean basins on the global climate system. Future research should continue to focus on identifying the physical mechanisms driving the tropical warming pattern to enhance our ability to predict its evolution. Moreover, further investigations into how these distinct interbasin warming contrasts between models and observations affect ENSO-driven teleconnections, both in the past and in future projections, are also warranted. Very important, considering right now we are in a record-breaking El Nino event that's growing like crazy. Had a little dip just recently in Niño 3.4. Doesn't mean it may go away, but predictions look kind of indicating Niño 3.4 warmer than 3 degrees, even when you take off the global warming tropical pattern in the so-called relative oceanic Niño index and so on. How the teleconnections of the 26 El Nino are being affected by the Indian and Atlantic Ocean warming is not being reported yet, but I have podcasts looking at predictions out to October and where we can expect dry, hot, humid, wet anomalies. These are from global models, so to the extent that they are doing warming patterns and El Nino, they may be closer to what is expected. So we don't necessarily have to separate El Nino teleconnections unless we are doing statistical forecasts by taking Nino 3.4 and trying to predict other teleconnection related local weather anomalies like maybe monsoon or health impacts and so on and so forth. Okay, let me leave it here.